So we're going to be doing functions first and then domains and ranges of functions. And you might be like, I already did domains before. Well, kind of. We're going to be doing some more complicated domains. So what is a function? If you look at its equation, you can tell. If you look at its graph, you can tell. You can also tell from a chart. It doesn't list that in this list here, but you know from an equation, from a graph, or from a number chart like an XY chart. You can tell me what domain and range means, basically the x values and the y values. Given a graph, identify the domain and range. So if I give you a graph, you should be able to go, I know the domain and range of that. That is not new. We've been doing that for a while. And last, given a graph, given an equation, identify the domain and range. So if I give you the equation, pro tip, what you're going to want to do is graph it. So it goes back to graphing. So if I said this one's been moved up 3, so look, this is at 3, then you'd be able to say its domain is from negative infinity to positive infinity, and its range is from 3 to infinity. Do you guys remember domains and ranges a little bit at least? Okay, so that's what we're about today. So everybody get to this slide here. This is a classic drawing. You put your x into the function and it spits out a y. If you had a machine, and there is such a machine, where you put in a penny and then you crank this thing and then it spits out the penny, except it's squished the penny and it has put like a little etching on the penny. I've got some of those from national parks. It's kind of cool. It's penny machines. You stick in the penny, and you actually have to put in other money too to pay them for it. And you crank the thing, and out comes the penny on the other end, except it's been squished and has like an indentation from the national park. Well, if you put in something like 25 cents into that machine, and it squished the 25 cents, and it came out with a squished 25 cents, then that would make sense. But if you put in another 25 cents, this time a black 25 cents, and it came out as 50 cents, that wouldn't make any sense. You know, you'd be expecting the same exact thing would happen, and that's the key with functions, is that if you put in the same x, you should get the same thing out. You shouldn't get 25 cents out one time and a 50-cent piece out a different time. That would be weird. Okay, so functions, when you put in something will come out. So these are all just read f of x, and I think you guys know that that's the same thing as what? Y. It's just y. All right. What's different about these functions? They just have a different degree, and this one's got an absolute value in it. And we just had a quiz on all that stuff, so it shouldn't be like that big of a deal. All right. So if I look at this, I can go, oh yeah, that's a function. Can you tell if it's a function or not? I can look at this and I can go, oh, that's not a function. And I know how, and I'm going to show you how. It's really simple. It says express y as a function of x. I will just say solve for y. Everybody take this one and solve it for y. The part where you were listening is done. This is the part where you actually need to do something. Trent, I feel like you're not with me. That one. Solve. So what do you do first, Annie? What's your first step? You're going to get y alone, so... You know? We're going to add 3x squared to both sides. I saw some people had that. Know why? You look to PEMDAS, and you always look and see, can I add or subtract anything that will get my y alone? Yeah, I can add 3x squared. Will we multiply or divide later? Yep, but first you look to add or subtract something. All right, now I got 3y equals... Notice me putting the 3x squared first. It's not illegal to write it the other way, but you may as well simplify it a little bit by putting the bigger power first. And now we have to divide everything by 3. Why? Because you get all your add, subtract stuff done, then you move to multiply or divide. And this 3 cancels this 3, so it's just x squared plus 2/3. You guys get that? Okay. So I solved it for y. Here's a really simple answer. If you can solve for y, and there's just one answer, which there is, y equals that, then it's a function. But can't you solve everything for y? No, you can't. Like, look over here. The first thing you do is add or subtract, because of PEMDAS backwards. You're trying to get y alone, so what are we going to do? Add or subtract? Come on, say it. Ethan T, what are we going to do? Subtract x. Excellent. And I'm going to put the negative x first. So that's going to annoy some people, but it's because I got my slope first. All right. Now from here, I've done my add or subtract. Can I fix this y squared by doing any multiplying or dividing? No. Is it an exponent that I need to fix? Yes, it is. So that's next. And how do I get that squared off of there? Square root. Square root, square root. Now, this is a really important moment because at this moment, you got to know that this comes out to the absolute value of y. A lot of people never knew that. They just thought square root will take off the squared. I get it. I totally get. A ton of kids think it's just y, but it's not. And the reason that that matters right here is that you know that absolute values break into 2 equations. Remember this deal, it splits into 2, but we're not going to even finish solving it. We're just going to go, look, there's going to be 2 answers. Y equals this, and y equals negative that. I just blew past a really, really big deal. Even in my honors pre-calc classes, nobody seems to know this, that when you take a square root of a variable, you get the absolute value. It's a huge deal. Let me show you why it's such a huge deal. Tons of you think when you have this, you just go square root, and x equals 4. And that's not exactly right. Because when you square root a variable, you get the absolute value of it. So you get x equals 4 and x equals negative 4. Think about it. You could put a negative 4 in there, and it would act just like a 4, and it would solve the equation. You get how there's 2 answers? That's something that at least 3 times this year, it's going to come up where you're going to have to square root a variable, and you'll have to know it's the absolute value. At least 3 times on tests. Middle of a test. You'll have to be solving for something squared, and you got to remember, oh yeah, when I square root a variable, it's the absolute value. Okay, so see how it came out to 2 answers? Well, same with the one we just did. This one, it came out to 2 answers because it was the absolute value of y. If it comes out to 2 answers, it's not a function. Remember, the whole goal is to tell if something's a function or not. And if you get 2 equations when you solve for y, it's not a function. Let me give you one. X equals 4y squared. What do you solve for? X? No, I'd already be done. We're going to solve for what? For y. So to solve for y, everybody write this one down. Solve for y. I just showed you how 2 seconds ago. Can you add anything? No. So don't bother trying to add something to both sides. Can you multiply or divide by something? All right. If I can't get participation that way, I'll just call on people and it's okay. I like it better when you got 2 or 3 people that just pipe up, but I can call. All right, so this is Iris. What's the next step?
Divide both sides by 4.
Divide by 4, you are correct. And now I've got to get the squared off of there. George, tell me how to get the squared off of the y. You are correct. And we just talked about this. What's wrong with what I just wrote? I just square rooted the y.
Absolute and absolute.
Yes, so that tells you there's actually two answers, which tells you this thing's not a function. All right, so look, two answers. This thing wasn't a function. Much easier when you're just looking at a picture of the graph. If I look at this and I go, will that pass the vertical, anybody remember the name for that? Vertical line test. Will this one pass a vertical line test? Yeah, because I can draw a vertical line at any place on this function and it only touches once. It never touches twice. That's called the vertical line test. The only function you're used to is a circle. That function, the only function you're used to that isn't really a function is the circle. Do you get, when you draw a line through a circle, you have one input of, let's say, 8, and you get 2 touches twice, you get 2 outputs. One input of x is 8, gives you like this spot at 8, 2, and this spot at 8, 6. You put in 8, you get 2 different things. It's like you put in a quarter in that machine and you get 2 different things out. That doesn't make sense. You're supposed to put in a quarter once, like the 8, and you get one thing out every single time. But if you start going to the vending machine and pressing the same button like A4, and you keep getting different things out every time, like this time you get a Kit Kat, this time you get a Snickers, and this time you get a can of pop, and you're like, what the heck? I can't keep hitting A4, same input. I should be getting the same output, but I got a 6 and a 2 because it doesn't pass a vertical line test. So here's another one. Everybody look at this one. Does this pass the vertical line test? Yeah, because it never touches twice. So it's a function. Does this pass the vertical line test? No. Because in this zone here, in fact, it even touches 3 times. Once, twice, 3 times. One input, inputs are the x's, and if x is like 7, right there, has 3 outputs, 7, 8, 7, 9, and 7, 13. Doesn't pass a vertical line test? Not a function. All right, so there's 3 ways to tell if something's a function. One is look at the vertical line test. Another, solve it for y, and if you only get y equals one thing, like y equals, even if it's weird looking, I don't care what it says. Doesn't matter if it's to the 3rd or the 5th or the anything, it doesn't matter. If there's just one y equals, see, look, one y equals, it's a function. It will be a function. But if you ever have like y squared at the end and then you got to square root it, not a function because you'll get 2 answers. Okay, let's move on. So, are these functions or not? Well, is this one a function? Yeah, it passes the vertical line test. That one passes the vertical line test. That one does not pass the vertical line test because if I put an input of -2, it hits it twice. 2 outputs. We get that the x's are the inputs. So I input a -2 and I get -2, 2. And I put in a -2 and I also get -2, 4. There were 2 outputs. Okay. How can you tell from just these? Well, you graph them. It's really easy. If you graph these and they pass the vertical line test, you're good. Now, kids after a while start getting used to like what they can just look at it and tell whether it passes the vertical line test. But at the beginning, you probably just have to sketch it quick. Over 1 up 4, over 2 up 5, over 3 up 6, over 4 up 7. You start going, oh, I see what's happening here. It's a straight line. Does that pass a vertical line test? Yeah. So that wins. It's a function. This one, if I graph it, some people think, oh, it's weird, so it doesn't pass a, no, just check. Over 3 up 6, over 4 up 6. See how that's still passing the vertical line test? It's okay if there's the same number here. That's okay. Because when I graphed them, look, if I draw a line through that, doesn't that pass the vertical line test? Yeah. Doesn't pass a horizontal line test, but it passes the vertical line test. How about 5, 7? Well, that means it went up a little bit. A second here. 3, 6, 4, 6, 5, 7, 5, 8, 6, 10, 10, 9, 11, 11. Does that pass the vertical line test? Yeah. Yes.
Wouldn't it not, because there's 2 5s and then it's 5, 7, 5, 8?
Uh-oh, wait a minute. Oh, I never noticed that one. I never graphed them all. Good catch. Over 5, up 7, and over 5, up 8. There was right there, there was a spot where it fails the vertical line test. Very good catch. Thank you. Kid watching at home on the video would have been very confused if they had, maybe they wouldn't have noticed those 2 spots, but look at that. Doesn't pass the vertical line test, not a function. Good catch, thank you. Okay, domain and range. Domain is all the possible x values. Range is all the possible y values. You could be asked for that on a test. It would be as simple as that. Domain's all the possible x's. Range is all the possible y's. So if I give you a graph and I say, what's the domain of this graph? I like to think of it this way. If that's the point 7, 3, do you agree that if I let this thing go and just keep going and going, it's going to keep going up and it's going to keep going to the right? It's going to keep going that way forever. This is going to keep going that way forever. So what's all my possible x's? Won't they go forever? So the way you write a domain is in interval notation, so it would go from negative infinity to infinity. You had this in higher algebra. Guarantee you had range and domain a million times, but it's been a while. The range is from how low it goes to how high. Remember, you always have to have your numbers in order from small to big. If you ever are writing an interval and you don't have the smaller number first, you are doing it wrong. It's going to happen on the test. It happens all the time. Kid will write from 3 to negative infinity. Negative infinity is smaller. It has to be first. Get what I mean? You have to have them in order from small to big. So, what's my range? My range is my y values. So obviously this 3 is probably important. And then does this thing go forever in both directions? No. The lowest it ever goes is right here, which is 3. So it goes from 3 to, what's the highest it goes? Infinity. So domain goes from left to right. Range goes from how low it goes to how high it goes. Domain's left, right. Range is low to high. Remember, it's got to be smaller number first. 3 is way smaller than infinity, so you should probably check those because it's going to happen. All right, here's another example of a domain and range. You remember the square root function, and it's going like that. And this is the point 4, let's say 3. Does this function, notice the dot, does this function go forever left and right? No. So what's the range of possible x's? All the x's you could put in, it would go from 4 to infinity, and I'm going to do it wrong on purpose. Can anybody catch me? It's a small thing, but it could cost you. Yes?
What should be in the bracket?
Bracket, very good. Because 4 touches. Do you remember the difference there? If something touches, like this touches 4. If it touches that spot, then it gets a bracket. Can you touch infinity? No. As soon as you get there to this really huge number, it's even bigger than that. So you can never touch infinity. So infinities have parentheses. And if you can touch the number, it gets a bracket. All right. How about the range on this puppy then? Well, it's from low to high. If you want to write that, I think it's always cool if kids are like reminding themselves what it is by going like that. What's the lowest this thing goes? And don't say 4, because that's the x value. What's the lowest it goes? 3. To what's the highest it goes? Yep, it's still going up. And then you just make sure, did I put the smaller number first? Yeah, I did. So, I'm telling you, it's really tricky to sometimes on the ranges, people will put the smaller number last by accident. On this one in particular, here's the trickiest one, because it's going down. So people are like, they get confused by this one, which I understand. I've gotten confused on it. 4, 2. That is a flipped over square root that's been moved. What's the domain? Does it go forever in both directions like this? No, it does not. What's the range? Remember, the range is like this, how low to how high. I totally get somebody's going to make this backwards, but I'm just trying to show you that educationally, a good teacher is supposed to know where the common mistakes are and warn the kids, this is where you're probably going to screw up. So you can watch out for that. Because there's so many little things to know that you can't be expected to know where you're likely to screw up, but I'm supposed to know where you're likely to screw up. So most kids on the domain, they know it goes forever to the right, but they've just gotten used to a lot of problems go forever in both directions. So this one, because there's a dot here, I reminded people, it starts at 4. Where is the common place to screw up? I did it on purpose to show you. What did I screw up on? Alex, you know? Bracket. I thought I heard you say bracket. My bad. Okay, then range. Range is from low to high, but so often people are like, yeah, I remembered it's 2, so I'm going to write from 2 to negative infinity, and why is that wrong?
Smaller number.
Smaller numbers got to be first. I get why people do it. They lock in on this 2, and they're like, I know that's in my range, so I'm going to put the 2 down. And they forget that when you're going to negative infinity, like how low you go. For some kids, this helps too, and I don't know who you are, but there's where regular infinities are. This is where negative infinities live. So if something's going that way, it's got an x component and a y component to it. When you're going kind of at an angle like this, that's an absolute value function, then it's going left and it's going up. So is it going to negative infinity or is it going to infinity? Well, it's kind of both. The domain is going from negative infinity to infinity because it's the x's. The range is going this way, and it stops right there. So you'd have to know that point was like 3, negative 4. Well, the range would be negative 4 to infinity. Okay, we are almost done, boys and girls. This is the parent functions, and they're all functions because they all pass the 3 words. They pass the what? Vertical line test. Very good. What's the one common thing that you use a lot? Circles. Do they pass a vertical line test? No, and that is not a function then. Doesn't make circles like illegal. It just means they're not functions. That means when you solve a circle, you have 2 equations for y. And they actually look kind of like they have square roots in them. And one's positive and one's negative. We're not going to get into detail on that, but circles are not functions. Okay, moving along. So last thing, and by the way, we get a chance to review this many times. The test isn't for a week from now. So do you get? I don't need you to be a master of this yet. So if you walk out of here with like, dang, there were some of those things I don't remember. We're going to practice it. The test is in about a week. All right, there's two kinds of things you have to watch out for. Square roots. Why? Because you can screw them up by having negatives under them. Do you remember that deal? You can't have negatives under square roots? So what happens? That means your domain is all the things you can legally put in, and you can't put in negatives under them. So if there's a square root, then you have a domain limit. You can't just put in anything you want when a square root. And how about denominators? They can't be 0. The top can be 0 in a fraction. Tons of people think that you can't ever have zeros. No, zeros are fine, except if they're on the bottom. All right. So the square root function has y equals the square root of x. Does it have an unlimited domain? No, because you can't put in negatives. So this domain starts here, goes forever that way. The domain would be from 0 to infinity. That's the domain. Notice it's not unlimited. It doesn't go forever on a square root. Why? Because you can't put in negative numbers here. And here's your graph of a 1 over x function. Does it go forever without ever stopping? No, because it has these asymptotes here. Put it on my desk, please. And here. And so now there's my vertical and horizontal asymptotes saying that this does not have an unlimited domain. The domain does not go forever in both directions. Everybody get to this one, please. Put a D and an R. And you need to look at this one with me because it's the hardest one, and you're in precalc. So you're going to probably get one of the hardest ones on the test. If you were asked for the domain and range of this thing, you would say, well, it kind of goes from negative infinity, because look, it's going forever right here. This thing, we know on the square 1 over x function that it actually should be arrows here, and there, and there, and there. But the trick is that people think then that it just has an unlimited domain, that it goes from negative infinity to positive infinity. But that's not true, because as you move from negative infinity back this way, it starts avoiding touching a number. And it never will touch that number, which is 0. So it never can be x is 0. Do you get, look at this graph, you cannot be at 0. There's no green dot in there. You can't have x is 0. So how do you write that? You say from negative infinity until 0. But then isn't there another part of the graph where it gets all the way to infinity? Yeah, from 0 to infinity. With a little union in between them. There is the domain. It goes from negative infinity to positive infinity. I want you to think of it that way. But it has a stop along the way, one thing it doesn't touch, which is what? 0. How about the range? Think about it. It goes from negative infinity to positive infinity with one thing it doesn't touch. It stops right there. It doesn't touch that. Then it keeps going up again. So it goes from negative infinity to 0, and then starts working again between 0 and infinity. It's exactly the same. The domain and the range are exactly the same. Domain is talking about x values, which can be everything except 0. The range is talking about y values. And this is a way of saying everything except 0. All right. This is a lot for one day, and I do pity the kids who are going to be gone, but they'll have a video to watch, and we will review it multiple times. So if you had to find this domain, you might just go, well, I know that it's not unlimited because it's a square root, so it looks like this, and it's been moved 3 to the left, so you might all know all of those things. But unless you actually graph this puppy, and graph it and go, it went 3 to the left, and it starts right there, which is at negative 3, 0. Unless you actually graph it, which you could, once you graphed it, your domain becomes easy. But what if you don't want to graph it? Because there will be complicated ones that you don't want to graph. Last thing I promise is this slide. I just have to show you this, so pay attention. Actually, dang it, there's one more slide. This slide and one more slide. Okay, so x plus 3, it needs to stay greater or equal to 0. I mean, this can be 0, can't it? Square root of 0 is 0, and that's okay. Zeros aren't bad. Zeros on the bottom of fractions are bad. Now, doesn't that look a lot like a problem we just did, except actually way easier? Could you solve that? Oh my gosh, it's so easy. X is greater than or equal to -3. So that's your domain. Look, I didn't even have to look at the graph. If I did look at the graph, it would have looked like this, which makes sense that it would be from -3 over. But I didn't have to even graph it. I just had to take this and set it greater or equal to 0. So same thing here. Take this, x squared plus 3x plus 2, and set it greater or equal to 0. And now this is the part where I still have a few of you who haven't got your factoring down. And I warned you. I said it so many times, you got to know how to factor, and yet on the test, tons of kids would just froze up and weren't able to factor things like this. Not tons, but like probably 4 kids in each, no, 3 kids in each class got stuck on the harder factoring problems. By now, you're supposed to be like, oh, that's easy. 2x, 1x, total of 3x, yay, it worked. And then there's a number line because it's greater or equal to 0. So this, we just got tested on this. You know, math doesn't let you just like, okay, we learned that unit, now we can forget it. Oh, we use that unit like right away. And you got to then test intervals to try to figure out where this thing's going to work. And we're finding our domain algebraically. Could I have graphed this? Yeah, but I seriously doubt there's a kid in the room who could actually graph what that looks like. You might be able to graph a parabola, but not a parabola that's been square rooted. That's saying that in a funny way, but it's a radical parabola. Nobody knows what that looks like. But if you do this little rule where you take what's underneath here and you set it greater or equal to 0, then you just have to factor it, and it turns into last test. How do you test and see if this thing works? Well, you check something that's up here. I like to check the big numbers first. Bigger than -1, heck, let's test 0. So easy. 0 goes here, 0 goes here. Is 2 greater than 0? No, it's not. So that's out. Now, I suspect that's going to work, and then that's going to be out. But I'm going to check. What's between -1 and -2? -1.5. So I go put it in. Testing intervals, just like on your test. And that's -0.5. And all it really matters is that it's got a negative on it. And this one's positive 0.5. And that comes out to a negative number. Is that bigger than 0 then? No. And I just checked. And that, I was expecting it to work. What's going on? 2 is bigger than 0. Oh my gosh, how did my brain just totally died there. 2 is bigger than 0. Cheapers. Sorry. For those of you that thought you were living in crazy world for a second, I apologize. 2 is bigger than 0. Yes, it is. I don't know why. I just could not see that. I tested this and expected it didn't work, but then it did. Do you get how I have got it? I just had it completely backwards. So, things that are bigger than 0 worked. So I should go draw the line and then shade it like this. Things that were in here, I just tried it. It came out negative, and that's not bigger than 0, so that did not work, which means this probably works down here now. So let's just be sure. So I'll test a number like -3. I'll stick it in here and here. And I get a negative number times a negative number. Doesn't even really matter what they are, because a negative times a negative will be bigger than 0. It'll be positive. So it worked, and so I shade here. All right. Wow, that was a challenging one, mostly because, look, I had to know that I take what's under the root, set it greater or equal to 0, then I had to factor it, which some kids still can't do. That's why I said you need to learn that first 20. Then you had to test intervals, which I said was the hardest part, and I even screwed up testing the intervals. So don't feel bad. If you tested the intervals on the test and you thought, just like I did, I was like, I'm sure that doesn't work, because I was saying 2 is greater than 0, and I'm like, how can I not see that it worked? All right, so testing the intervals is the hardest part. All right, so then this is, I promise, the last slide. So there's no square roots, but there is denominators. Is it okay if the top is 0? Yes. Is it okay if the bottom ever becomes 0? No. So then you want x minus 3 should not equal 0. This may be the first time you have written an equation with a not equals symbol. You solve them just like normal equations. Add 3, x cannot equal 3. Because look, if it put a 3 in there, the bottom becomes 0. Anything divided by 0 doesn't exist. Minus 4, x not equal negative 4. This might be the first time you've ever written an equation and then solved it with a not equal symbol. Those are your answers. X cannot be 3 and x cannot be negative 4. So if I was going to put that on a number line, I would say, here's my number line. Here's where negative 4 is, and it can't be that. Here's where 3 is, and it can't be that. But it can be everything else. No need to test intervals. I know it can be everything except those two numbers. I really hope we don't make you write these in interval notation, just because it adds a whole nother step. But if you had to, it'd be negative infinity to negative 4, union negative 4 to 3, union 3 to infinity. But I'm hoping we'll allow number lines for this test, but we'll see. There, you made it. All I got to do is take these and say x plus 2 cannot equal 0, and x squared plus 1 cannot equal 0, and solve those equations. X cannot equal negative 2. And this one's weird, because when I subtract 1, I get x squared cannot equal negative 1. Square root. Do you remember that thing I just did 2 seconds ago? Absolute value of x cannot equal square root of negative 1. And now you have to think, can I square root a negative 1? No. So this means there is no solution. I'm okay with that. I'm okay with a 0 with a slash through it. That means empty set. I'm okay with DNE does not exist. There is nothing that would ever make it equal 0. Now let's talk about that for a second. That means you can put in anything in the world, 0, and it still doesn't equal 0 because it adds 1. What about negative 1? Nope, because then when you square it, it turns into regular 1, and it won't equal 0. There's no way to make this equal 0. There's no way to make it equal 0. There is a way to make this equal 0 that's really simple. So your final answer is just, there's no way to make this part 0. So the only answer is x cannot be negative 2. There's your domain for that one. If I was going to put it on a number line, I would draw a number line with a negative 2 on it and say it can be anything except negative 2. All right, so I want to give you your final test, and this is going to be super, like, quick review. Do you get there's a thing called the vertical line test? Does this thing pass the vertical line test? Yes. What if I put a little loop-de-doo in it? Will it pass the vertical line test now? No, because one input then would give you 3 different outputs, and that's not okay. So this one is not a function. This one's not a function because it'll have more than one answer. To get that? If I solve it for y, it'll have more than one answer, so that's not a function either. Because when I do this deal, I get the absolute value, which makes me split it. And I'll have 2 answers. So it's not a function. Not function. Okay? If I give you a problem that has a denominator like this, you go, oh, you're saying x cannot be -7. Yep, that's the domain for that one. You could put in anything else you want. The only thing that won't work is -7. And if I give you this one, you got to set this part. This is the hardest part. X plus 7 is greater or equal to 0. And do you remember that deal where now you'd have to solve it, and then you have to make a number line? And this one's actually pretty easy. Here's -7. It can be -7 because it's or equal. And then I'd shade to the right. Set these greater or equal to 0. Say that these cannot be 0. And now you've learned everything. We will review the heck out of this. And if you feel like you've already got it, you might be surprised when you actually go look at problems that are like this. That like, wait a minute, I thought I understood this. Now, the good news is, I just needed to teach you everything today. And there's no homework because of the singleton thing. So, welcome to one of the only nights ever where there's no homework at the end. We'll pick this up and take it from there tomorrow.